Welcome. So today we're going to go on to section 523. And we're going to talk about some family of logarithmic functions. So today we're going to make sure we remember how to go from log to exponential and exponential to log, knowing that those are inverses of each other. And then we're going to play around on Desmos, and we're going to look at those bases. Remember the b or the base when it came to those logarithms and or exponential functions, and see how they change, and for you guys to kind of come up with a kind of some rules in a sense that go along with it, so you can find out these little family of functions. Yes, ma'am.
I got a pee so bad. Can I please go?
Yes, you may. All right. So under 523, what did we learn about logs? So we're going to do a little investigation on those logs. So earlier we've learned how to write those exponentials to logarithms and those logarithms to exponentials. So just a little bit of an overview. So if we had our logarithm, so if we had y equals log base b of x, if we wanted to find the inverse, what do we do first?
Switch x and y.
Switch x and y. Right? So we would have x equals log base b of y, right? And then we want to be able to solve that for b. So right now, the way that it's written, we kind of don't know how to manipulate this logarithm, so we're going to change it into an exponential function. So to turn it into an exponential function, what are we going to do? Our base is b, right? Raised to the exponent of, x, and that's going to equal y, right? Remember those good little guys going back and forth between the two of those? Granted, the ones we worked on yesterday had numbers and variables in there, but this one's just kind of our little rule. So what we're going to do now is we're going to hop on over to Desmos. So make sure you guys all go to desmos.com for me so we can do this together. Well, I'm going to set it up for you, and you're going to set it up on yours, and then you're going to play around with it. All right, so in Desmos, go to the graphing part of Desmos, and ultimately we're going to put in these two equations. We're going to put in the logarithm, and then we're going to put in its inverse written as an exponential. So give me a second to hop over to Desmos. So usually when you just put in desmos.com, this little guy pops up. So we want to go to the graphing calculator, so we're going to click on the graphing calculator. And our little graph's going to pop up. So under our first little part to put in our equation, we're going to put in the logarithm. So we had what? Y equals, make sure you're on Desmos so you know how to put these in.
Okay.
Thanks. Yep. When it comes to putting in the logarithms, click on it to where you get that little keypad. And if we look at it the way it is right now, we don't see log, do we? So we're going to investigate under our little function button. And then they kind of split it into 4 different little categories. If we were working on trig, statistics, distribution, and then miscellaneous. And then under miscellaneous, there are 2 different logs that are written. We're in a base 10 system, so when you just see the word log and there's nothing else written on that, it's always going to be a base 10 because that's what our normal counting system is in, right? But we're getting away from log base 10s, so if you see the log right next to it where it has that little base written as that little a, that's what we're going to click on. And then you can see your little cursor, it went down into that little subscript in order to put in your base. And our base was b, right? And then we have x. And this one just, it automatically puts that parentheses after the base. Like you don't have to have that parentheses, but Decimals just puts it in automatically for you. It kind of helps when you have more than just one number or one variable to keep it all together. And then you're going to hit enter because it has that little add, whoops, well, before I hit enter, it had that little B slider because remember we're going to mess around with those bases. So we're just going to hit enter because we're going to play around with that base here in a minute, that B, that base. Boom, 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 boom.
What's that base?
Boom.
Do I just put in B or do
Yep, you're going to put in B for right now.
Okay.
Because you're going to investigate how, when we change that base, how it changes the equation. Everybody good so far?
I added the slider.
Awesome. Yep. And then now we're going to put in our inverse. And when we took our inverse, we sat there and solved it for y by finding that exponential. So we had y equals, and then it's b to the x. So we can't have b squared, right? Oops, put my b in there. We want to be able to change that. So we're going to, whoops, I lied. Oh, to the x. There we go. Right? Sound good? I'm going to change these colors. If you want to know how to change the colors, if you click on the equation and you hit the little gear guy and then you go over to the colors, you can change the colors. And I'm just changing them so because they show up better. If I do like purple and orange just up on the screen for you guys, it just kind of shows up a little bit better. And hit done. And then I'm just going to move my B down. You can leave it there. I'm just going to pull it down. You can rearrange all of these just because I know that that's what I'm going to mess with. So I'm going to give you guys a couple minutes. You're going to play, so on that slider, if you just put your little cursor on there and you move it, it kind of gives you different values. And we're just going to look at those values between 10 and negative 10, but I want you to kind of go through those values and see if you can come up with some interesting facts, or what is it, things that you notice about different values. Sound good? So I'm going to give you two, 3 minutes for you guys to play around with that. And then we'll come back and see what we come up with. So be ready to share out some wonderful information that you come up with. Sound good? All right. So now that you guys had some time to play around with it, somebody give me one thing that they noticed. One thing that you noticed. Yes.
When B equals 0, both of the lines are the same. What equation is this?
When B equals 0, both lines are the same. Yep. And like I said, it's kind of hard to see just on up here, but remember how we had that orange and that purple? It's this little line down here. Is it a line that goes on and on forever?
I don't know.
Well, it looks like it's going this way, right?
Yeah.
Do you notice anything else? Does it go this way?
No.
Oh.
It's a curve.
So if we think of our domain, our x values, when our base is 0, like our domain would be from 0 to positive infinity, right? We don't have any. Right? All right. I like that one. Yep. So when it's 0, when our base is 0, right? What else did we notice? Yes.
When it's at 1, it's like a never-ending line.
When it's at 1, hold on, let me get to 1. Oh, yep. So when our b is 1, we get a straight line. They match up, right? Both of those equations are there. It's kind of hard to see that because it kind of hides the purple one behind it, but we don't see the purple anywhere else. So at 1, it's the same line, same horizontal line, right? And it's a horizontal line at a value of 1, right? Because if we just look at our exponential one, if I put where this is a 1, it doesn't matter what my x value is, right? If I have 1 to the 10th, 1 to the 10 is 1, right? Because that's 1 times 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 1, right? So it doesn't matter what my x is if my base or my b is 1. So I'm always going to get that line. And on this one, what would my domain be?
2.
Isn't it infinity?
Yeah, right? Domain are my x values, so I'm going from negative infinity to positive infinity, are all real numbers. What's my range value? What is that, my x or my y? When I talk about range.
y.
Range, right? What's my y value? What's my range?
2. Wait, 1.
It's 1, right? Yeah, it's 2 little squares, but yeah, it's technically 1, right? No, I get what you're saying. Yep, so my range is actually 1. And I don't have any other y value other than 1, right? So yeah, so if it's 1, we get that straight horizontal line. Anybody notice anything else? Yes.
Between 1.1 and 1.4 they cross, and then after that, when it gets higher, they like move away from each other.
Ah, yeah. So from that 1 kind of going up, they kind of cross over each other. Oh, now they cross over each other twice.
And when
Crazy.
you reach 1.5, they
Yep.
split.
1.5 they split, and then they kind of keep. Nice. Yep, as it gets higher on that positive value, right? Whoop, they kind of spread out maybe a little more, something along that lines. Yeah, yeah. I like it. I like it.
That's all I got.
Anything else? So we talked about 0, we talked about 1, we talked about greater than 1. What else could we talk about? Zero, 1, and positive. Is there anything else? It starts with an N.
Negative.
Negative. What happened when you guys went to negative numbers?
Yeah.
Nothing showed up, right? So when we got to these negative numbers, yeah, sometimes you get these dots that show up, right? Right? So in decimals, like those little dots, they're kind of like imaginary numbers, like they don't exist, right? So we're looking for these solid lines that give us a graph. So when it gets to the negatives, we can't have negative logs, right? So what happens when it comes to our bases, in our logs, our base, we can never have a negative base. So that's something to remember, right?
What would that mean if you did? Would it be like no solution?
It would be no solution. Yep, absolutely. Absolutely. Yep. So somewhere in our notes, we probably should like jot a little bit of this down, right? We can't have negative bases for logs, right? We don't get an equation. When our base was 1, we had that straight horizontal line, right? And I wonder if we could say anything about these positive values. Do they have any kind of symmetry to them? Maybe? Anybody remember when it came to those inverses, what those inverses do graphically? There's a line of symmetry somewhere. Anybody remember what that line of symmetry is?
No.
So remember when it comes to finding the inverse, what do you do with the x's and the y's?
You switch them.
You switch them, right? So whatever was the x now becomes the y, and whatever was the y now becomes the x. So those x's and y's are actually equal. So it would be the line when y equals x. So I'm just going to change the look of this. It is a line, but I'm just going to make it this dotted line. And I'm going to make it black so it stands out, right? Just to make it look different than, I wonder, can you even see that those are dots?
Yeah.
You sure?
Mhm.
All right. Just so that way, I mean, it's still a solid line. It's not discrete in individual points. It is a solid line, but just to show. So now when I do my slider, are they reflected over that line? Are they the same distance going whichever way from one to the other? Right, like if I thought of this, right? So to get to this point, like this point is this far away from that line. If I went the opposite direction, would it be that same distance?
Yeah.
Yeah, it would be, right? So when it comes to our logarithms, our purple, or our exponentials, our orange, they're reflected over that line of symmetry, right? And it doesn't matter where we are, we're still reflected.
It's not a huge.
Sound good?